Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Is everyone hear my voice?
Boleh doktor.
Hmm.
Waalaikumsalam doktor.
So how are you? All of you? Makan kuih raya banyak tak? Kau tak makan kuih raya?
Raya hilang terus.
Terus tak ada mood raya?
Makan doktor, makan.
You all okay tak tu kat rumah?
Okey doktor. Doktor okey.
So far Alhamdulillah, I pun okay. Yelah macam sedih je lah kan. Takkan walaupun tak dapat raya balik kampung, dapatlah juga raya dalam daerah ke ataupun dalam negeri. Rupanya pun tak dapat. Malah lagi teruk nak pergi rumah jiran pun tak dapat kan? Sadis je.
Betul.
You all ada yang kena swab ke? Ada yang kuarantin ke? Ada?
Alhamdulillah tak ada.
Okay, kalau ada you all private message I lah. Okay, sometimes I can understand your feeling. Sebelum ni pun I pernah kena swab juga. Tahun lepas akhir tahun, bulan 12. Tapi tu pun consider CC1 lah. CC1 sebab kita ada seorang positif. Tapi sekarang even kat UMP pun ada kes kan. You all tahu kan kita ada kes juga dalam 3 orang kot. 3 ke 4 yang positif. Jadi you all pun careful lah kat mana pun you all ada, kat mana berada. Yelah bukan tak boleh nak pergi mana-mana tapi jagalah SOP. Kalau tak perlu tak payah keluar sebab I rasa this time macam different sikit. Dia punya infection tu dia macam spread sangat. Maksudnya even kalau kat Kuantan ni kalau you tengok lah area Kuantan kan macam mana-mana semua ada macam tu. Even taman saya ni ada 2 kes kot. Yelah kita kan sometimes kita tak ada pun lah berfikir nak dapatkan. Kadang-kadang kita tak perasan, tu je. Jadi you all harap jaga diri, okay. Kalau tak perlu keluar, tak mau keluar. Tapi kalau nak keluar, yelah sometimes kita nak release stress juga kan. Boleh tapi jangan terlalu lama, jangan pergi tempat crowded, okay. Jaga SOP jugalah, alright. Sebab I rasa kalau positif, mungkin kita punya emosi mungkin akan terganggu jugalah kot. Kan bila nak belajar ke apa, then risau ada, sedih pun ada mungkin. Okay. So, how your study? Applied Stat, okay tak?
Chapter 4 tak faham.
Tengok video ke tak ni? You tengok video.
Saya lost lagi.
Sikit doktor.
You all kena ingat chapter 4, 5, 6 markah banyak dekat final juga. Okay. So make sure chapter 4, 5, 6 tu you all kena apa ni? Kena betul-betul faham. Sebab chapter 4, 5, 6 tu dia macam senang. Dia macam straightforward. Nanti I tunjuk sikit. Maksudnya kalau dia nak one way ANOVA, itu yang you belajar, itulah yang dia nak. Kalau chapter 3, dia macam ada banyak kan, dia hypothesis testing tapi dia banyak situation. You macam bila baca soalan, you kena tahu ini dia nak yang mana. Tapi kalau one way ANOVA, two way ANOVA, okay, chapter 4 tu memang apa you belajar, itulah yang dia nak je, tak ada lain. Okay. Alright, so kita start chapter 3 saya cuba summarizekan. Okay, sebab I rasa last class saya dah summarizekan part A, satu bahagian traditional method. Okay, so now I will summarize second part, hypothesis testing using p-value method and confidence interval method. This one sometimes in exam, in final, instead of they ask traditional method, they ask you using p-value method and confidence interval method lah. Okay, so you should know how to do that. Okay, most of the steps sama. Okay, step 1 sama, most of the steps sama lah. Okay, but different way how to decide macam tu je. And then I will go through chapter 4. So chapter 4 I will summarize as well. Okay, I think this week you should watch the video. Okay, so I will summarize. Chapter 4 we only have 1 week ANOVA, 2 week ANOVA. Okay, 1 week ANOVA you should know how to calculate manually. But 2 week ANOVA you no need to calculate manually. You just look at the output. Okay, and then I believe if you have looked your assignment part 2, it's about chapter 4. Okay, 1 week ANOVA and 2 week ANOVA. So if you can do that, inshallah lah, you can do for final as well. All right. Okay, so I go through first chapter 3. Wait, I didn't present it. All right. So this is chapter 3. Okay. Let me show you first. We try look at here. Okay. Okay, right. Alright, so basically in chapter 3, we are talking about hypothesis testing. So hypothesis testing, we have 3 methods, okay? First is traditional method, okay? And then we have confident interval method, okay? Confident interval method. And then third is p-value method, okay? So this one you've done, okay? I've done summary. This one you have 5 steps, okay? So this one is if you have 4, if I'm not mistaken, but it's still 4 and 5, okay? But the first step, you write down your H0 and H1, okay? Actually similar with this step, okay? Method 1. Here it can be anything, all right? It can be mu, it can be 2 population mu, you can be 1 population variance, okay? 2 population variance, you can have proportion, okay? However, when they ask you to use confident interval, at this sign, you only have equal and not equal. Okay, that's important. You only can solve hypothesis testing using confident interval if you have this one. Wait, I think someone coming. Yes. Okay, that's why sometimes I'm asking you to come early so that no need to interrupt your friends. Okay, but it's okay. Sorry. This one. Ke you all terkeluar sebenarnya? Okay, right? Okay, so your first step, okay, you must remember if they ask you to use confident interval method to solve the hypothesis testing, you only have this situation, equal and not equal. But here it can be anything lah, okay, what you have learned in chapter 3, okay. And then step number 2, you calculate your confident interval. So how you calculate confident interval? It's similar with chapter 2. Okay, you've done chapter 2, isn't it? So you've calculate based on chapter 2 knowledge. Okay, so similar. If one population mean, you look the condition. Is it population variance known, unknown, and so on? You follow lah chapter 2. And then here finally you will have 2 answer, A and B. Okay, and then step number 3, you decide reject or do not reject H0. So how you reject and do not reject H0? You look the value of 0 or the value of here. Is it in the range or not? Okay, if not in the range, what should you do? Here, you can see here. If theta naught is not in the range, reject H0. Okay, that's mean you look the value is here. Sometimes it's 0, sometimes it's 20. It depends on question, isn't it? All right, so look this value. Is it in the range or not? If not in the range, reject H0. If in the range, do not reject H0. And then step number 4, conclude as usual. At alpha equal to what? All right, what you get? Okay, so you can see you have 4 steps here. So basically step 1, similar. Step 2, you learn in chapter 2. Step 3, you must know how to reject and do not reject H0. So you just remember one part lah. If theta naught is not in the range, reject H now. Okay, so if it's in the range, do not reject H now. And then draw conclusion is similar with previous lesson. Okay, all right. So that is confidence interval. Okay, hypothesis testing using confidence interval. Now using p-value method. So when using p-value method, you still have 5 steps, if I'm not mistaken. So step number 1, you have similarity. Write down your hypothesis testing. So this one again, it can be anything. Okay, this one similar with here. All right, it can be equal, greater than equal, less than equal. All right, it can be anything. Step number 2, all right, actually usually in this p-value method, you no need to find the p-value manually. Okay, previous semester or your very super senior learn how to calculate the p-value. Okay, but in your case, okay, I think have been 3 or 4 years good. All right, the p-value usually we get it from output. Okay, Excel output. For example, this is the output. Okay, so this one, this is the p-value. Okay, we have the formula lah for sure how to do it. All right, and then another example, this one. All right, so you can see this is the p-value method. This is important. Okay, for final, even in the future, if you do your final year project, okay, when you analyze your data, you must know which one is your p-value. Okay, so I'm going back first, the step 2. So you can see that you will have p-value, right? So p-value here, it depends on output. Okay, is it 1 tail or 2 tail? It depends on your hypothesis testing. And then step number 3, you decide your alpha. So alpha usually in exam given lah, what's the value, okay? But if they didn't given anything, you should assume 0.05, okay? In the future, if you do your final year project, this alpha, you will determine yourself, okay? It can be any value which you want, okay? Which you want to test. So step number 4, right, reject or do not reject. Okay, how you reject and do not reject. Reject, this one you must remember until you work, okay, because you will use this often in the future, okay. So reject H null when p-value less than alpha. So this is p-value that you get from output, and this is alpha that you state yourself. I mean, in exam given lah, okay. If not given, 0.05. But in the future, if you are researcher, you can have your own value here, okay. So usually we have 0.05. If you do for medical data, maybe alpha should be 0.01. Okay, because we deal with health, we deal with life, people, right? So 1% should be the error, okay? So this is how you reject. And then step number 5, conclude as usual. Okay, conclusion. Okay, so I give one example for p-value method so that you can see the sequence. But I believe if you have watched the video, you can see clearly. Okay, this is the step how you do it lah. Okay, but you can go through the slide and video for sure. But I just want to show you this one. For example, where's the example? This one, okay. Let's say this example, okay. So a firm is conducting a study. Okay, it's quite similar lah. The approach or the concept is quite similar with final concept. Okay, given a situation like this, and then given a data, and then sometimes given data, then they give you the output straight away like this. Okay, give the output. Then they ask you to do what? So if you look this question, you can see that. I go through the example, okay. A firm is conducting a study to compare 2 different physical arrangement of its assembly line. Okay, so the one you clear, question, first sentence. they want to see or they want to compare two different physical arrangement of assembly line. Okay, it has been determined that both arrangement yield approximately the same average number of finished units per day. So you can see here, same average number of finish. Okay, but it's not really clear yet. Is it they ask for mu ke, variance ke, proportion ke? Okay. Alright, next, the arrangement with the smaller variance in the number of finished unit produced per day will be adopted. So you can see that here is highlighted lah. So you can see that's the main objective they want to see. Okay, but in the exam, they will not be like that. Okay, it will be very usual font. Okay, but you must look carefully. So here you can see that the arrangement with smaller variance in the number of finish will be adopted as the new arrangement for its assembly line. So that's the keyword. Okay, when we have smaller variance, okay, either line 1 or line 2, we will adopt or we will use that arrangement. So the result of two independent random samples are shown in table below. All right, so you can see that you have line 1, line 2. So if you look this data, is it dependent or independent? Is it independent or dependent data? Anyone? Are you with me or not?
Independent.
Independent, okay? Because you can see lah, line 1 is line 1, line 2 is line 2. Okay, but I think if you look test question before, it give you some trick. Okay, it's independent but you do dependent, or is it dependent you do independent, something like that. But you must clearly see. Okay, so this one is independent, and it doesn't matter here independent or dependent, because if you look the question, using 0.01 significant level, do the data support the claim that assembly line 1 will be adopted? Okay, and you can see it's not straightforward. It says that assembly line 1 will be adopted. So how you transform to hypothesis testing? So first, you will have H null and H1. So what is the parameter here? Is it mu or is it variance? You look back here, okay? Claim that assembly line 1 will be adopted. So look again here. How this assembly line 1 will be adopted? Assembly line 1 will be adopted if line 1 has smaller variance. Alright, so this is the parameter, the keywords. Alright, the keywords is variance. So when we are talking about variance, you will have, you will have here one variance. Oh, wait, I don't know why this one is not working. So we look here, this one. Okay. I'm not sure why my pen doesn't work here, but so here lah, this one. Okay, when you say that is less than, okay, this one, smaller variance, that's mean less than. You don't have equal sign. Okay, so you don't have equal sign, it will give you at the H1. Okay, you need to write down here. Geramnya I, kenapa pen I tak working ni? Alright, so that's means your claim is at H1, okay, because smaller than. What is smaller than? Variance 1, because line 1, okay. So when you have smaller here, alright, so here you will have greater than. So basically here, if you do traditional method, it will be at the left side, okay, and alpha should not divide by 2. and this is chi-square distribution. This is F distribution because you have two population variance. All right. So here they show you how to do the F test using Excel. Okay, basically in exam, you will have this output. Okay, so you can see that line 1, line 2. That means the hypothesis give you variance 1 less than variance 2. Okay, sometimes line 2 will be at the left side. So this one will be the other way around. Okay, so this is the population, this is the sample mean. Okay, this is the X bar. This is the S square. Okay, sample variance. So this one you can see like the sample size. And then this is the degree of freedom. This is the F test. Okay, if you remember, if you do traditional method, this one you calculate yourself using the F table, the F test. Okay, so this is the p-value. Okay, so if you look here, they mention one tail. So if you look your hypothesis testing, is it one tail or two tail? One tail, isn't it? So if one tail, this is your straight away p-value, 0.0152. If, okay, if here is two tail, okay, if your step number 1 is two tail, this one you need to times with 2. Sorry. So when you times with 2, you will get for two tail p-value. Okay, so that is step number 3. So step number 4, you decide reject or do not reject H-null. So again, remember, reject H-null when p-value less than alpha. So if you look p-value here is greater than 0.01, so do not reject H-null. Okay, so usually in the paper, I mean, if you do finally a project or if you do research in the future, usually they will say, is it significant or not? So what does it mean significant? When you can reject H-null. All right, that means it's significant when p-value less than alpha. That means you reject H-null. So in this case, it's not significant. Okay, because you do not reject H-null. All right. So step number 5, you conclude as usual. So the alpha value is very important. And then what is your finding? What is your conclusion? Okay, because you can see here, do not reject H-null. What does it mean? Line 1 will be not adopted lah. Okay, because the population variance is not smaller. The population variance of line 1 is not smaller than population variance line 2. Okay, so is that clear? Is it clear or not?
Yes, Doctor.
Okay. Any question? Do you have any question?
No, Doctor. No, Doctor.
All right. So that is hypothesis testing. Okay. And then in hypothesis testing, there are one part which is type 1 and type 2 error. Okay. So type 1 and type 2 error, if we have it in exam question, maybe 2. The maximum marks will be 3 marks. Okay. It depends on your hypothesis testing. But the most important here, you should know that this box. Okay. So, and then you must know lah type 1 error when you reject H-null, the box lah, okay, the box is important. So if you sit here, if you look here, okay, state of nature means commonly or usually known, H-null is true, okay, but when you do the hypothesis testing, you reject H-null. So you will get type 1 error, which is usually alpha, okay. But let's say your nature, which is your H-null is true, then you do not reject H-null. That means you get correct decision, no error. Okay. So the other way around, okay, if your H-null is false, okay, naturally is false, but then when you do hypothesis testing, you reject H-null, that means you get no error. Okay. But if you do not reject H null is false here naturally. So you will get type 2 error, which is beta. Okay. So important. This is naturally. Okay. In nature, this is what you have. Okay. But when you do the hypothesis testing, if you get reject H null, this is what you get. If you do not reject H null, this is what you get. Okay, so the concept of this box, you must understand. And then you try adapt with the situation you have. Okay, so you could try example. I believe you can see this one in video. Okay, and then you can also try exercise past exam question. Okay, I will ask you to do that later. Then we can see how good you are or how understand you are. Okay. All right. So that is chapter 3. Any question for chapter 3? Anyone? Question? No.
No.
Okay, good. So now I can close this one. Now we move to chapter 4. Okay. So chapter 4, we are talking about analysis of variance, or we call it ANOVA. Okay. If you are third year, fourth year, if you do final year project, this analysis is very important. Okay. Usually you want to compare more than 2 population. If you look chapter 3, we have until 2 population only, isn't it? For example, previous example you have variance 1, variance 2. Okay, we cannot have more than that. Okay, for chapter 3. But chapter 4, you can have more than that. Okay, so we have one-way ANOVA, two-way ANOVA. Okay, so one-way ANOVA, you only have 1 factor. Two-way ANOVA, you have 2 factor. Okay, so this is actually pre-method lah, not pre-method, it's early method of DOE, design of experiment. Alright, if you learn design of experiment later in the future, in your I think it's considered in your faculty course. Not faculty course, your field course. Okay, DOE. If you do experiment, you will learn design of experiment and how you want to design experiment. So you will have lah many other method. But one way and two way ANOVA ni is very simple method lah to be used for DOE. Okay, so I'll believe that you learned or you read, you watch the video. Okay, so again, here I want to show you one way ANOVA. We have 1 factor only. Okay, and then there are some assumption lah. Okay, that assumption usually, where's the assumption? This one. Okay, this assumption usually you will consider when you do the analysis. Okay, and then this is how you calculate manually. Okay, this is the model, this is the rule. All right, and then again, we still have 5 steps of hypothesis testing, but here instead of 1 or 2 parameter, we have 1 or 2 population, we have more than 2. Okay, you can use this notation or you can use sentences. Okay, but here this is how you do it. Okay, you cannot do like this, mu1 not equal with mu2 not equal with mu3. This one is wrong. Okay, you must do like this. And then if you want to do in sentences, you must have the word at least 1 population mean is different. So you can see in chapter 4, we only talking about mu only. Okay, and this mu more than 2 population. For example, you want to compare student performance, okay, in many different schools. So you have Alu-Aka School, you have Methodist Girls School, you have Gambang School. So you have more than 2 population. Alright, so you use mu only. So that's why I said in chapter 4, whatever you learn, this is what they will ask. Okay, so if one way ANOVA, this is one way. Alright, so this is step number 2. This is step number two, sorry, that one step number one, this is step number two. So step number two, this table is very important. Okay, so all the formula here is given. This one you must remember. So you must know what is K, what is capital N, all right? And then how you get mean square, you must know. Okay, and this is the F test and this is the critical value. So you refer F test. If you do F test, you will refer F table. All right, so that's step number two. Step number three, this one actually considers step number three. This is step number four, which is how you reject. You only have one way to reject. We reject H now when F test greater than F table. Okay, you only have this situation. You will not have less than ke, okay, to side ke, no. You only have greater than, okay. Although here equal, here at least, but here is greater than, all right. So after you have a decision, reject or do not reject, then you will conclude as usual. Okay, so this is example. Okay, so you can see here, this is your K. K equal to 4 because you have 4 group. So each K ni, you have how many sample size? 5. Okay, but sometimes we also have different sample size. For example, this one. Here you have 4, here you have 3, here you have 4. Okay, so different. So if you look assignment letter, it's quite similar lah. All right. So this important. Okay, you must know how to calculate this one manually. Okay, and again here at this part usually student make mistake because you can see here this is similar, isn't it? 5, 5, 5, 5. Okay. If you look exercise just now, this one we have different value. So when we have different value, here will be different value as well. Okay, and you must remember if you calculate SS treatment, what is the value here? It's a total for each row or each column. Okay, in this case, each K ni lah. Okay, square divided by the sample size. But SS total, each of the cell, you must square plus. Okay, here is similar. Okay, here is similar, which is from here. Grand total, square divided by grand sample size. How many you have? 5 times 4, you get 20. And then SS error is very easy lah. SS total minus SS treatment, you get this value. And if you do one-way ANOVA, you will not get negative value. Okay, you must get positive value. If you get negative value, that means something wrong somewhere. You need to calculate back. Okay, but usually students make mistake at this part lah. You don't remember what is it. So make sure you be careful at this part. And here, right? So in this table, all should be positive. You will not get negative. And if you look, the name of the analysis is analysis ANOVA. It's analysis of variance, isn't it? So when it's variant, it will be what we call it. Should be positive. Okay. I angkat sekejap Assalamualaikum. Sorry Are you with me?
Yes, doctor.
Really sorry ada orang pula hantar barang, I kena turun. Okay. So, important, I think the last words I say about positive value. Okay. So, in this table, you should get positive value on. Alright. And yeah, you still have 5 steps. Okay, this is considered hypothesis testing as well, but we are talking about one-way ANOVA. Okay, right. So now, any question with one-way ANOVA? Anyone? No. If no, then okay, we move to two-way ANOVA. Okay, all right. So two-way ANOVA, I mentioned just now, you have two factors. Okay, usually in your experiment, you have two factors lah. For example, surface roughness. So surface roughness, it depends on what? Maybe what the quality of the type of the type of what you call yang dia akan maybe the type of how you measure the surface roughness? Surface roughness you can measure, or you can, it depends on the type of material maybe, and then the type of drill, for example. All right, so you have two factors there. Okay, or maybe if you are chemical people, what is it? But you have two factors lah. All right, so two-way ANOVA, you also have assumption. So before you do the two-way ANOVA, you have this assumption, and you need to follow the assumption. And important here, okay, this is very important as well for your assignment. You can see here, okay, each cell or each combination, you should have at least 2 samples. Okay, you cannot have 1. You must have 2 and above. Okay, so this is example. You can see again. We have also model, and here model we have interaction. Okay, because we have factor 1, factor 2, we have 2 factor. So we have each factor, factor A, factor B, and we also have interaction factor. Okay, and this is the assumption of two-rule study. This is your step number 1. So step number 1, you don't have any parameter, you have in sentences. So usually when you do two-way ANOVA, you want to look first, is there any interaction between factor A and factor B or not? And important here, usually students make mistake at this part. Okay, they confuse, or they usually the other way around. They put H null and interaction. So you must remember at H null, no interaction. At H null, no effect. H null, no effect. All right. So first, usually they will use this first. They will do this this hypothesis first. There is an interaction effect or not? If there is no interaction effect, they will look here and here. Okay, so you have 3 hypothesis testing here. First, you look there is interaction or not. If no interaction, they will do row effect and column effect. All right. So this is the formula, and again in your batch, or I think more dah 2-3 batch kot, kita tak ajar you manually. Okay, this one no need to memorize the formula ke apa. Okay, but when we give you the output, you must know how to read the output. So I will straight to the output. This is if you calculate manually. Okay, we can do this. Okay, but nowadays, okay, even in the future when you do final year project, you will have the output. So we just look at the output. So I'll straight away go using Microsoft Excel ni. Alright. I go to two-way ANOVA first. This one. Okay. So consider example 4.2. Okay, so actually consider 4.2 tu example yang manually calculate tu. This one. Okay, so you can see that you have 2 factor here, reagent and catalyst. Reagent you have how many? 1, 2, 3. Catalyst you have how many? 1, 2, 3, 4. Okay, and you can see each combination, that means A1 you have at least 2 sample. A2, 2, A3, 2. And each of the cell must be similar sample size. Okay? You cannot have different such as one-way ANOVA tadi. No. Okay? So this is important. When you read the question, you can see, oh, this is two-way ANOVA because you have two factor. Okay? So if you look the output, so you will have this. Oh, sorry, this is one way. This one. So you will have this output first at the beginning. So you can see lah A, B, C, D. Okay, factor. And then you have region 1, region 2, region 3. Another important here, how do you know it's a column factor or row effect or column effect? So you look at the data. Okay, if you look at the data ni, you can see this is factor A. The column will be factor A, region. And then you have row factor is catalyst. Okay, now usually students also confused which one is factor A, which one is factor B. So usually in matrices, okay, if you learn matrix, we call column first and then row, isn't it? Row ke column first? You can see lah, the row is catalyst, the column is the region. Okay, so this is the output. Okay, so this is the summary only, the average, the variance. So basically here, if you look, this is your X bar, this is your S square. Okay, this is the summation. Okay, so this is for the catalyst and region, the combination. But most important, this table. You must understand how to read this table. Okay, so you can see that you have sample column interaction. So sample is your row, column is your column. That means sample is your catalyst. Catalyst. Column is your region, and this is the interaction, right? So the first or the main, the first thing that we want to see is there any interaction or not. So if you look this interaction, okay, usually we just use p-value. Right, so again, how do you know reject or do not reject H null using p-value? Reject H null when p-value less than alpha. So that's why I said p-value method ni, you will use it in the future. Okay, even until you work. Okay, so if you look p-value here, 0.5, and then your alpha is 0.05. So do not reject H null, isn't it? So when do not reject H null, you have no interaction. So when you have no interaction, you need to do the row and column effect. So that's why you will have this hypothesis. You have the same step, but now for row effect, you will look p-value for row effect. Okay, if column effect, this one, you need to look this p-value. Okay. So instead of p-value, you also can use f-test and f-critical. So similar. How to do that? Reject H null when f-test greater than f-critical. So this one greater, isn't it? So reject H null. But if you look interaction, is it greater than this one? No, isn't it? So do not reject H null. So you will get the same answer. Either you use p-value or f-test. Okay, is that clear? Do you have question? Anyone? Do you have question or not?
No, doctor.
Okay, so that one is two-way ANOVA. So I just want to show you for one-way ANOVA. Okay, sometimes we give you this output as well, because in final it depends on the lecturer lah. What they want to ask, isn't it? Okay, but basically whatever you learn, they will ask. Okay, so this is if we give you the output of the one-way ANOVA. Okay, sometimes we fill in the blanks ni. So one-way ANOVA ni, there are many ways lah. We can ask you, either you calculate manually from the beginning, from the scratch, or we give you this table and then we remove some value, then you need to calculate. Okay, so for one-way ANOVA, you must know from the scratch how to calculate. Although given this output, you can fill in the blank. Okay, so similar, the concept is similar. Okay, you can use p-value method to decide, or you can use f-test and f-critical. Okay, but make sure you understand how to read this table lah. Okay, so here they use between groups and within groups. So within group is the error. Okay, between group is the treatment. All right. All right. Any question for one-way ANOVA and two-way ANOVA? No, isn't it? It's very straightforward. That's why I said usually student can score more on chapter 4, 5, 6. Because whatever you learn here, this is what they will ask. Okay? So for those who get poor marks in the how many? The last midterm tu, which is 34% tu, you can start from chapter 4 if you want. Okay? Alright, any question for this one? Any question, guys? No. Don't sleepy don't sleep. Dah bukan bulan puasa dah ni, boleh makan. Alright, so I go through the assignment, part 2. So the assignment part 2, 3% je. Although 3% is very important. Okay, because it can give you A. It can give you A minus. Although it can give you pass sometimes. Okay, so make it serious. Okay, although it's 3%. All right, and it's an assignment. Okay, you can ask anyone to answer. All right. So if you look assignment, due date is 11th June. Okay, again use Kalam. If the Kalam cannot, have problem, then I will give some other platform lah. Okay. So part 2. Have you read the assignment? Have you read or not? Not yet. So I think you still have time, 2 weeks time, and it's not really difficult. Okay, you can see from my previous explanation for one-way ANOVA and two-way ANOVA, right? So this is the instruction. Okay, use Microsoft Excel and p-value approach, right? And then this is how to submit, and then this one will not entertain usually lah. All right, so you can see question number 1. All right, so read the scenario. I will not discuss too detail here, but you can see this is for chapter 4. That doesn't open here. You can see this assignment requires you to conduct analysis of variance using Microsoft Excel. So you just use chapter 4 slide just now, and then look. So we have 2 questions here, and just now I mentioned we have one-way ANOVA and two-way ANOVA. So if you look, first question here, how many factor you have? How many factor?
3.
Pardon?
3.
Bukan. You tengok I baca, okay? Bukan you je. Terima kasih sebab jawab. Kalau orang lain mesti dah ke laut juga. Kalau you tak jawab, diorang pun cakap 3. Okay? Thank you to you. So business 2.0, first annual employment survey provide data showing the typical annual salary. Okay, for 97 different job. Table 1 show an annual salary for 30 different job in 3 fields. Computer software, hardware, construction and engineering. Nampak sangat lecturer ni salah ni juga ni. So you nampak ada berapa? Okay, kat sini consider computer software and hardware lah. Okay, here computer software and hardware, construction, engineering. Alright, so kalau tengok sini kita ada satu je factor, salary, annual salary. But this annual salary dia groupkan pada 3, computer, construction, engineer. So ini adalah one-way ANOVA sebab dia ada annual satu factor je. You boleh compare dengan this one. Even kalau you tengok table ni, you nampak dah, you ada automobile, you ada gasoline. And bila you baca, you boleh nampak a research firm test the miles per gallon characteristic of 3 brand of gasoline. Okay, because of different gasoline performance characteristic in different brands of automobiles, 5 brands of automobiles are selected. So you can see that the performance, okay, ataupun dia nak check tu, dia guna 3 different brand and 5 different automobile. So kat sini ada 2 faktor dia consider untuk tengok performance. So kat sini ada 2 faktor, so dia adalah two-way ANOVA. Okay, so don't again, sebab tu kita kata student sometimes confused kat situ. So macam mana nak reduce the confuse, you kena tengok banyak soalan tutorial tu. So then you boleh, bila tengok je, dah tahu, ni one-way ANOVA, contohlah. Okay, alright, so you jawablah jawapan A apa, jawapan B apa. Okay, kalau you tengok B, dia kata randomly generate data to fill up table 1 using random number generated in Microsoft Excel. So this one, you tak guna sebelum-sebelum ni, tapi this one, dia ada dalam modul kita chapter 1. Dia ajar you macam mana nak guna random number using Microsoft Excel. Sebelum ni, I touch guna calculator. Okay, I touch guna calculator. Tapi bila kita ada sistem ataupun ada Microsoft Excel lebih mudah. Okay, so you pergi buka Excel, you cari and then you masukkan range value dia. Alright, so you nak berapa? Tengok kat sini you nak berapa. It depends on you. Okay, kalau tengok sini dia kata the number of data for each job must not necessarily the same. Maksudnya kalau sini you ada komputer ada 4 lah, kalau sini 6, terpulang kat you. Okay, and then bila you dah dapat data tu, baru you proceed soalan nombor C dan D. Okay, so it's very straightforward, but if you have problem, for sure you can ask me. Okay, you nak tanya betul ke salah pun tak apa. Betul tak yang ni? Macam ni ke? Contoh. Okay, even dekat Excel nanti, kalau you macam confused, nak generate random number tadi tu, pun you boleh tanya. Okay, WhatsApp lah as usual. Okay, and then start question number 2. This one I mentioned, you have 2 factor. So it's two-way ANOVA. And then you can answer question number A, question number B. Okay, try your own first. Okay, I don't want to give the answer yet. Just give you some guide how to do it. So if you look C, similar. You will use random number as well. Okay, but now instead of 2 factor, you have instead of 1 factor, you have 2 factor within this range. And then here must be the same. That means for each cell ni must be the same at least berapa? 2 data, 2 sampel. Okay, and based on C that you get the data tu, you will analyze the data. Okay, so they want to see interaction. Okay, if you get no interaction, you must do row effect and column effect. If based on your data you get there is an interaction, stop. No need to do the row effect and column effect. Is it clear?
Yes, Doctor.
Alright. So again, the same members. Okay, the same members. So easier for me to. But if your members, I don't think there are or there is a student drop. Okay, so you can have the same person, the same group members. However, if you have sleeping partner, let me know. So I give you her he or he, she sleeping partner marks. Okay. All right. So any question for assignment?
No, Doctor.
Madam.
Alright, so you still have time, many times ni, but if you can done or do it early as soon as possible, I think only spend 2 hours or 3 hours, it can be done, okay? Because chapter 4 is straightforward, and then you see the guide too, and with my help, okay, I mean if you ask me through WhatsApp ke apa, insyaAllah, you can be done by 2 or 3 hours je. Okay? Right. So, no question
No, Doctor.
Okay, so I think that's all for today. Alright, and it's 1 o'clock already as well. So again, if anything, let me know. Try manage your time. Don't feel procrastinate. Jangan melengah-lengahkan kerja. Okay, sebab kalau you melengah-lengahkan kerja, nanti banyak terus, you akan stuck kat situ. Stress pun ya. Kan stress terus mengamuk pula kat rumah. Alright, so try your best, manage your time. Buat sikit-sikit, lama-lama jadi bukit lah kan. Sama juga exercise. Okay, make sure you try your own. Understand the video, try one exercise per day. Or maybe kalau applied stat ada 2 kelas kan, buatlah sehari 1 soalan. Okay, tak faham boleh tanya I. Jangan melengah-lengah. Maksudnya kalau you nak study last minute, sometimes memang tak jadilah. Okay, sebab mathematics ni memang you kena faham, practice, then insyaAllah you boleh jawab dengan lebih baik. Okay? Alright, so I think that's all for today. Thank you so much. Be careful, take care. Assalamualaikum.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor. Thank you, Doctor.
Thank you, Doctor.
Thank you, Madam.